Let's draw parallel lines P, Q, R and S. Now draw a triangle ABC. Next, cut out this triangle. Place the triangle on one of the parallel lines, say line R, such that the base BC of the triangle lies on line R. With the help of the parallel lines, draw a line parallel to BC. This parallel line intersects triangle ABC at points E and F. Now, let's measure the ratios AE, EB, AF and FC. Record these ratios. Next, let's change the position of the triangle. Place the base of the triangle BC on another parallel line, say S. With the help of the parallel lines, draw another line besides EF that is parallel to BC. The new parallel line intersects triangle ABC at points X and Y. Now, let's record the ratios of AX and XB and AY and YC. Look closely at the two pairs of ratios. What do you observe in each pair? What can you conclude from this activity? The ratios in each set are equal. So, we can conclude that if a line is parallel to one side of a triangle and intersects the other two sides at distinct points, then the other two sides are divided in the same ratio. This is the basic proportionality theorem. It is also known as Thale's theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points, then the other two sides are divided in the same ratio. In triangle ABC, line segment DE is parallel to BC. Line segment DE also intersects side AB at D and side AC at E. Now, let's prove that segments AD and DB are divided in the same ratio as segments AE and EC. Next, join BE and CD. Then, construct EF perpendicular to AB and DG perpendicular to AC. The area of triangle ADE is half the product of its base AD and its height EF. Similarly, the area of triangle BED is half the product of its base BD and its height EF. The area of triangle CDE is half the product of EC and DG. The ratio of the areas of triangles ADE and BED is equal to the ratio of AD to DB. Similarly, the ratio of the areas of triangles ADE and CDE is equal to the ratio of AE to EC. Triangles BED and CDE have the same base DE and lie between the same parallel lines DE and BC. Therefore, the areas of triangles BED and CDE are equal. As the areas of triangle BED and triangle CDE are equal, the ratio of AD to DB is the same as the ratio of AE to EC. Now, let's see the converse of the basic proportionality theorem. If a line divides any two sides of a triangle in the same ratio, then that line is parallel to the third side of the triangle. In triangle ABC, a line DE intersects AB at D and AC at E, such that the ratio of AD to DB is equal to the ratio of AE to EC. We have to prove that DE is parallel to BC. Suppose DE is not parallel to BC, then let another line DF is parallel to BC. As DF is parallel to BC, by Thale's basic proportionality theorem, the ratio of AD to DB is equal to the ratio of AF to FC. It is given that the ratio of AD to DB is equal to the ratio of AE to EC. Therefore, from steps 1 and 2, the ratio of AF to FC is equal to the ratio of AE to EC. Add one or both sides and simplify. We get FC equals EC. This is possible only when E and F coincide. In other words, E and F denote the same point. If E and F coincide, then DE coincides with DF, and thus we can say that DE is parallel to BC. In triangle PQR, ST is parallel to PQ. It intersects side RP at S and side RQ at T. Find the length of RS. Since ST is parallel to PQ and intersects side RP at S and side RQ at T, we can apply Thale's basic proportionality theorem to find the length of RS. Next, put in the known values. Thus, we find the length of RS. PQRS is a trapezium. PQ is parallel to SR, and the diagonals intersect each other at point O. Prove that the ratio of PO to OR is equal to the ratio of QO to OS. It is given to us a trapezium PQRS in which PQ is parallel to SR and the diagonals SQ and RP intersect at point O. We have to prove that the PO to OR is equal to the ratio of QO to OS. Construct segment OT parallel to PQ such that it meets PS at T. In triangle PRS, TO is parallel to SR. By Thale's theorem, the ratio of PT to TS is equal to the ratio of PO to OR. In triangle SPQ, TO is parallel to PQ. By Thale's theorem, the ratio of PT to TS is equal to the ratio of QO to OS. Therefore, from the above steps, the ratio of PO to OR is equal to the ratio of QO to OS.